I'm Anil Kumar, and I'm going to discuss with you exploring equivalent trigonometric functions in this video. Now, one of my students said, "Sir, I have to learn 12 identities for this chapter." Well, it is not 12 identities. It is just two simple concepts which you need to understand. And this is what I'm going to talk about in this video. So the concepts are to understand how to relate principal and related acute angles. That is the first concept which you need to understand. And the second one is the cofunction identities, right? That is it. Once you understand these two concepts, you can actually relate with the 12 identities you're talking about. So let's begin with relating principal with related acute angles. So in a coordinate plane, we have 4 quadrants. And in the first quadrant, that's the first quadrant, all trigonometric functions are positive. In second quadrant, sine is positive. In third quadrant, tan is positive. And in the fourth quadrant, cos is positive. You have different ways of learning. Cast rule, all silver teacup, and so on, in which quadrant what is positive. Now that is first thing which you know, right? Now let us also see what is the related acute angle and what is principal angle. Then we will relate them. Related acute angle, it is also sometimes referred to as reference angle. Now the name suggests acute, it means always it is less than 90 degrees. So it is somewhere in quadrant 1, let us say. That is our related acute angle. In general, we like to write it as alpha or something like that. Now as you can see, in quadrant 1, all trigonometric ratios are positive. Now, what is the principal angle? Now the principal angle will be the angle which is measured counterclockwise from positive x-axis, kind of like this. Do you see that? Like this. So that becomes the principal angle. So this line, which is called the terminal arm, will be making an angle of theta with horizontal x-axis, and this angle theta is your principal angle. Now principal angle could be from 0 to 360 degrees. We could write this principal angle as combination of related acute angle, right? So most of the time we prefer to write principal angle as, if it is in this quadrant, right, we could write this as 180 degrees, or let me use radians, since most of the students are using radians. So we could write, if you're in quadrant 2, we could write this principal angle as pi minus alpha, right? You could write this in quadrant 3 as pi plus alpha, and if in quadrant 4, you can write this as 2 pi minus alpha, right? Depending on which quadrant the terminal arm is, right? So this is quadrant 2, this is quadrant 3, this is quadrant 4 for you. So why I didn't take pi by 2 minus alpha, those combinations I will take under cofunction identities. Okay, so that is how I'm kind of splitting it up so that it becomes simpler for you to also understand when to use which identity. So if you are using plus minus with pi or 2 pi, then you follow this set of description which I'm going to discuss with you. But when we talk about pi by 2 or 3 pi by 2, we'll talk about cofunction identities, correct? Now, so you understand one part, that the principal angle could be written in this form, right? Now the second part you also understand is in which quadrant which trigonometric ratio is positive or negative. So if we have sine in quadrant 2, let's say quadrant 2, right? So if we have sine here, that means sine of pi minus alpha. We know sine is positive, therefore it should be equals to sine alpha, right? But if we have cos in quadrant 2, since cos is negative, we have to write this as negative cos alpha, right? Since everything is positive in quadrant 1. So cos alpha will be positive, we have to make it negative. So that's equivalent to cos of pi minus alpha. So that brings us to the name of the chapter, which is exploring equivalent trigonometric functions. I hope you get the point. Now, let's move forward. If we have something in quadrant 3, then it could be written as sine of pi plus alpha. Since both sine and cosine are negative here, we have to write them equivalent to sine of alpha, right? But if we are talking about tan, so let us say tan of pi plus alpha should be what? Now tan is positive, therefore it should be written as positive tan alpha. You get the point, right? You can fill up with other identities also in this. Now let me just complete it by writing cos of pi plus alpha should be equal to cos with a negative sign of alpha. You get the point, right? Now if you are in quadrant 4, then in quadrant 4 only cosine is positive, rest are all negative. So we can write sine of 2 pi minus alpha as minus sine alpha, cos of 2 pi minus alpha as plus, because cosine is positive itself as such, okay? However, tan of 2 pi minus alpha will be minus tan alpha. Now since quadrant 4 only cosine is positive, so cos will have a positive term. So I missed one of the terms, which is tan of, let me write here, you can fill it up, tan of pi minus alpha should be equal to what? In quadrant 2 tan is negative, so it should be negative tan alpha. So you can fill that up. So that is how many? 9 of your identities, correct? But a simple concept, that is in which quadrant which ratio is positive or negative. In quadrant 1 all are positive, and so you can relate them. I hope this point is well taken. If not, you can write your comments, share with me, and I will be glad to answer your questions. Now let's look into the second part, which is cofunction identity. So if you have a right triangle, so let me make one right triangle to help you out understand this particular topic. Now that's so simple. So in a right triangle, let us say if I have some angle, let's say theta, let's say this angle is theta for me. Then the other angle has to be 90 minus theta. Sum is 180, right? So take away 90, you're left with 90, take away theta. So that gives me 90 minus theta as the other angle. Now, if you are looking from theta point of view, then let me write these sides as, let us say, A, B, and C. Okay. So if you are looking from theta side, right, in that case, what is sine theta equals to? Sine theta is equals to A over C. Is that okay? Now, if you look from 90 minus theta side, then what is sine of 90 minus theta? So the other angle has to be 90 minus theta, right? So if from that side, 90 minus theta is B over C, correct? B over C. Now let's look into the cosine function. Cos of theta will be what? Cos of theta is adjacent over hypotenuse, so it has to be B over C. However, cos of 90 minus theta, when you look from here, adjacent is A here and C. So it is A over C. Do you see? So when you change your angle or perspective, things flip, right? So you can easily see what happens. So sine theta is actually A over C, which is same as cos of 90 minus theta. So that is how they are related. We call them co-function identities. Sine with cos, cos with sine. Either way, right? So you see, the other way also. Cos of theta b over c is same as sine of 90 minus theta. Correct? Isn't that obvious? Right, it is. Now similarly, you can explore tan, right? So for tan, let me write down. So what is tan of theta? Tan of theta will be a over b, right? And what is tan of 90 minus theta? You could write pi by 2 minus theta, okay? So tan of 90 minus theta is b over c. Oh, sorry, b over a, right? Now let's relate it with its cofunction. Cofunction for tan is cotangent, right? It's cot. So cot of theta is b over a, and cot of 90 minus theta is, if you see from that side, a over b. A over b, right? So you can see here also, tan theta has a cofunction identity, cotangent 90 minus theta. Do you see that relation? So whenever we are working with 90 minus, right? So we always get the cofunction with the same sign, right? That's kind of important. When I say 90 minus, then I'm minus the angle. I'm always in quadrant 1. Since I'm in quadrant 1, all the signs are positive. So 90 minus theta angle will always give me the cofunction with the same sign. Do you understand? Because all are positive in quadrant 1. Do you get the point? So that is cofunction identity. Now, these are your 12 identities you're talking about. You can now explore what will happen if you are in quadrant 2. It becomes 90 plus theta. Do you understand? 90 is pi by 2 for you. So if I have sine of theta plus pi by 2, let me write, then I'm in quadrant 2. Since sine theta is positive, I will write this as cos of theta. But if I have cos of theta plus pi by 2, then cos is negative in quadrant 2. Therefore, it should be equals to negative of sine theta. Do you get the point? So if you follow combination of this with what we learned earlier, you should be in a position to write all the cofunction identities with theta plus pi by 2, theta minus pi by 2, or plus 3 pi by 2 or minus 3 pi by 2. As an exercise, do that and try to understand the way I'm trying to explain here. I hope that helps. If there is a question, you can always email me or request on the YouTube. I hope that helps. Thank you and all the best.